Hello everyone, welcome to my YouTube channel techspot. This is me Harishgoupale. So basically in this video we are going to discuss about system verilog reduction operators and shift operators. So basically there are total 6 operators belongs to the system verilog reduction operators, that is reduction and reduction or reduction XOR, reduction NAND, reduction XNOR and reduction NOR. Okay, and the main thing is all operators perform bitwise operation between different bits on a single operand. Now how it is performing bitwise operation between different bits on a single operand, that we will see while implementing the system verilog code that will be based on all the operators, all the reduction operators. Now if I talk about shift operators, so we are having two shift operators, that is shift left and shift right. And shift left operator performs left shift on two operands. Similarly shift right operator performs right shift on two operands. Now how? For example, let's say we are having two operands. Operand 1 value is 4 and operand 2 value is 1. So operand 1 value, that is 4, will be shifted towards left or right. That will be depends on the operator by 1, that is the operand 2 value. Okay, now how it will perform the operation, that also we will see while implementing the code. Okay, now let's move towards the screen where we'll implement all the operands, all the operators on a system verilog code. Okay, so here on my screen you can see I have already written a code for the design implementation of reduction and shift operators. So first we will understand this design code line by line. Then I have write simple TB code to verify that design code of reduction and shift operators, and then we'll see the waveforms. Okay. So first understand this design code. So here you can see my module name is reduction and shift operators, and I have two 5 bits operands, A in and B in. And as we know that reduction operators returns the result in a single bit because they performs operation between bitwise operation between different bits, okay, of a single operand. But here I'm performing a shift operators also. So to perform the operation between shift operations, we need two operands, and to perform the operation for reduction operators we need only single operands. Okay, so A in and B in of 5 bits. Now my first output is reduction and which is single bit, as we know that reduction operator returns the single bit output, and our second operator is output reduction or, that is also single bit, then reduction XOR, reduction NAND, reduction NOR, reduction XNOR. Then two outputs again I am having, that is shift left and shift right of 5 bit only. Okay, then always at the rate star. So as we know this is combinational procedural block, and star operator automatically adds the sensitivity list. Sensitivity list means what? These are these input and output signals. Okay. Now inside the procedural block, what I did, I have assigned bitwise AND of A in to the output reduction AND, then bitwise OR of A in to the output reduction OR, bitwise XOR of A in to the output reduction OR. Similarly with reduction NAND, reduction NOR, reduction XNOR. And inside the and I have assigned A in shift left to with B in to the output shift left, and A in shift right operator with B in to the output shift right. Okay, then end module. So this is the design code. Now if I'll click on the schematic, so it will generate the schematic. Okay, 1 minute. Hmm. So here you can see my A in 4 down to 0, that is 5 bit. Now like as we know, reduction operator performs operation on a single operand. So this is a reduction AND operator, reduction NAND, reduction NOR, reduction OR operator, reduction what XOR, and reduction, no sorry, reduction XNOR and reduction XOR. Okay, and these are the output. Now to perform the shift left and shift right, we need two operands. So this is the first operand for 5 bit, second operand, and the output shift left and shift right. Okay. Now I will click on the TB code. So we'll understand TB code. A module name is TB for reduction operators. Similar inputs and outputs. AB of 5 bit, then these are the single bit of outputs, reduction and or XOR, NAND, NOR, XNOR, and then left shift output, right shift output of 5 down to 0, 4 down to 0, that means 5 bit. And then this is the instantiation, and inside the initial begin I have assigned some value to the A and B after 10 nanoseconds of delay. Now I'll click on the run simulation. As I already run this, we'll directly click on this waveform. Now this I'll click on this. Okay. Okay, so the first you can see my first input is 1 1 1 1 1, all 5 bits are 1. Okay, now for reduction and output we have assigned bitwise and of A. So here the output is high. Now why high? So see, operation will start from the MSB bit. MSB bit from means from this side. So 1 and 1, as we know the truth table of AND operator, if both operands are 1 1, then only output is 1, otherwise output is 0. So 1 and 1 output is 1. Again 1 and 1 output is 1. Again 1 and 1 output is 1. 1 and 1 output is 1. So final output will be high. So here you can see output of reduction AND is high. And we know that NAND is the inverse of AND. So if AND is high, then NAND is obviously low. Now come to the reduction OR. In the reduction OR, we know if any operand is high, then output will be high. Otherwise, output will be low. So here we'll calculate. Here we'll perform the bitwise. 1 and 1 obviously 1. 1 and 1 obviously 1. Output will be 1. Again 1 and 1 output 1. Again 1 and 1 output will be 1. So our final output will be high. Now we know NOR is the inverse of OR. So if OR is high, then obviously NOR will be low. Okay. Now come to the reduction OR. Now we know the truth table of reduction XOR. If both inputs are inverse, then only output will be high. Otherwise, output will be low. Okay. So 1 and 1 0. Okay. Now 0 and 1. Uh, 0 and 1 1. Now 1 and 0 0. 0 and 1 1. So here reduction XOR output is final output is 1. Now we know XNOR is the inverse of XOR. The if XOR is high, then XNOR will be low. Okay, so this is how reduction operators perform operation bit by bit between different bits. Okay, now come to the left shift operator. Here you can see the left shift operator where operand A is 1 1 1 1 1 and operand B value is 1 1, means 3. So the operand A value will be shifted towards left by 3, and the right hand side bits will be filled with zeros. Okay, so here you can see output this 1 1 all will be shifted towards left for the 3 bit, and remaining 3 bit will be shifted will be fulfilled with the zeros. So here you can see the output. This value is shifted towards left, and the bits as the operand B value is 3 and it was shifted to by 3, so remaining 3 bits are fulfilled with zeros. Okay, now similarly with right shift, this operand A value shifted towards right with 3 bits. So here you can see MSB, the bits from MSB initial 3 bits are fulfilled with 0, and the value shifted towards like this. So output we got here 3, and here we got 8 and 16. 16 plus 8, 24 we got output. Okay, so this is how all the operators work here. So in this video we have saw reduction operators and shift operators. 6 reduction operators we saw, 2 shift operators we saw. The main thing is all operators are synthesizables. Okay, as we saw in the schematic. So here I will stop the video, and if you are new to this YouTube channel, then please subscribe to my YouTube channel. Also, if you are like this video, then please click on like button. Okay, thank you so much.